In this video, we're going to look at the general steps to evaluate an improper integral. So first, you recognize this improper integral probably because you have infinity on the upper or lower limit, sometimes both. So the first step we need to do here is to rewrite the integral. So here we're going to introduce another variable b as our upper limit instead of the infinity. Because infinity, it kind of is not a defined value. It means you are approaching to a really, really large number. So here, we're using another variable b to help us to make the definition more clear. So as b goes to infinity, our boundary becomes from 1 to b, and our function stays the same. Okay, so now we have a standard definite integral. So our second step is to solve the definite integral. Your function might look different than mine, but in our case, we have 1 over x squared plus 4. We recognize that's a form of 1 over x squared plus a squared, where a is equal to 2. The antiderivative of that is 1 over a arc tangent x over a. That's probably somewhere in the back of your textbook if you don't remember, which is totally fine. Based on this equation, we know the integral of 1 over x squared plus 4 dx. The solution for that is going to be 1/2 arc tangent x over 2 plus c. But don't forget, in here we have a definite integral, which our boundary is from 1 to b. So our result becomes, we want to plug in 1 and b into the equation, which we would get 1/2 arc tangent b over 2 minus 1/2 arc tangent 1/2. And we don't have the plus c in this case. Okay, so now you have finished the second step. The third step, last but not least, is to take the limit as b goes to infinity. Because don't forget here, the b is kind of a arbitrary variable that we created in order to replace infinity. So we still need to plug in b as infinity and see what answer we could get. And in our case, let me draw the graph for arc tangent. It might be easier to visualize it that way. So we can see here as arc tangent goes to infinity, so as we can see from the graph, as the limit of b goes to infinity, 1/2 arc tangent b over 2, which is this part over here, is going to be 1/2 times pi over 2. Because as b goes to infinity, we look from on the graph, which we have a horizontal asymptote that goes to pi over 2, which is going to be pi over 4. And this part over here remains because arctangent 1 over 2, there's not too much you need to do to simplify it. So from this point, we get our final result. The integral of 1 to infinity 1 over x squared plus 4 dx. The result is going to be pi over 4 minus 1/2 arc tangent 1/2. So you see here in your final answer, the variable b does not exist anymore. And this is how we evaluate the improper integral.